Hello everyone, my name is Nick Meszaros. I'm a geology graduate student at the University of Texas. One of the things that I love about geology is that it gives you a way to create stories of the past, to explain how a volcano erupted hundreds of years ago, thousands of years ago, or even longer. It can also tell you how mountains were formed, and it can also give you information about the environment that a community of fossils once lived in. And for my research, what I want to do is I want to tell the story of how magma storage conditions beneath Valles caldera, which is pictured right here, changed before its last supervolcanic eruption. And as you might notice, this picture of Valles caldera doesn't look like a traditional volcanic landscape. And one of the reasons for that is that it hasn't been a volcanic eruption here in probably about 70,000 years. So one thing that we do know, though, is that beneath Valles caldera today, there's still a little bit of partially liquid magma. And that raises the possibility that maybe you could get a volcanic eruption in the future, whether it be supervolcanic or not. But one of the things that we don't know at Valles caldera is how did the magma storage conditions before the last super eruption, for example, pressure, temperature, and chemical composition, how do those compare with what we see today? And that is one of the problems of Valles that I want to try to solve with my research. So to do that, I want to look at volcanic rocks that I collect out in the field at Valles. And the thing that's nice about volcanic rocks is that they all started out as magma beneath a volcano. So if anything is going to potentially record these different characteristics like storage temperatures, storage pressures, and chemical compositions, it would be these volcanic rocks. And today what I really want to focus on is just one of those, talking about the storage temperature. So how can we get that temperature information from these rocks? And the cool thing that I find really fascinating is you can actually use these crystals inside the volcanic rocks to act as thermometers. And that's what I'm going to walk you through in a basic process of how that kind of works today. So first thing, like I said, is we collect these samples out in the field. And this is what they typically look like on the left. This is a pumice clast, and it's full of crystals that you might be able to see a few of them right here. I'm going to circle just a couple of them. And those crystals potentially can be used to tell the temperature of the magma before it was erupted. But before we get into that, the very first step is to take this volcanic rock that we collected out in the field and turn it into a microscope slide, or a very, very thin slice of rock that's about as thick as one of the hairs on your head. And this is kind of a difficult thing to do. You have to use several kinds of very high precision saws to cut the rock carefully, and you also have to grind it down very slowly to make sure you don't lose your sample. But at the end result is a beautiful looking thin section like this. So this is what one of those thin sections would look like under the microscope. On here, all of the different shapes that you see represent different crystals that grew in the magma, whereas the orange background part is the liquid part of the magma, or what would today be preserved as volcanic glass. So to turn these crystals into thermometers, we want to use something called an electron microprobe. And what we're going to do is we're going to bombard certain areas of the crystals with electrons. And we're also going to bombard certain areas of the glass next to those crystals with electrons. And when electrons hit either one of those surfaces, they're going to cause X-rays to be emitted. And characteristics of those X-rays will be dependent on what elements make up either the crystal or the glass. So when the electron microprobe then measures those X-rays and the characteristics of them, you can then figure out what the chemistry or the composition of your crystal and your glass are. By comparing those two values together and doing a little bit of math, you've then turned your crystal into a thermometer, and you can figure out how hot your magma was before it erupted. So it's really as simple as that. And this is one of the key fundamental things that I want to do to start to characterize what some of those storage conditions were at Valles caldera prior to the last supervolcanic eruption. So I hope you enjoyed this video, and thank you for listening.